Okay, our objective today is to learn the basic geometry concepts. We're going to finish up the extension from yesterday, and then I'm pretty sure we're going to move on to lesson 6.4, which relates really well to the extension. Okay, so that's a plan for today. First thing we'll do is go over the warm-up, and then we will go over the homework from yesterday. Okay, some of you came up and put the answers up, so let's see if these are right. Number 1, proportions for 1 through 6 are all proportions. Number 1 is 36. Number 2 is 1.6. Or 8/5. Number 3 is 1.2. Number 4 is 1. Number 5 is 22. Those are all correct. Mike, what did you get for number 6? Good. Okay, before we flip to the 2 proportion word problems, does anyone have any questions on 1 through 6? Grace? Yes, I can. Let me move this here. Is it okay if I move this? Everyone checked? Steve? For number 6? I'm going to do it in a second. Is it okay if I move this? Yeah. Okay, let's do number 6 here. Okay, number 6, we have 15 minus x over 45 equals 15 over 75. So make our butterfly. That's the first thing. Okay, we're going to take 75 times, and then in parentheses, 15 minus x equals 15 times 45 is 675. You got that for the first step? Okay, do me a favor, Miss Wingrove will sign that for you. Just walk back there. Okay, so step 1. Step 2, you need to distribute 75 times 15, 75 times negative x. After you distribute, we end up with 1125 minus 75x equals 675. You still have that? Okay. And then I would move 1125 to the other side, because you want all the numbers on one side, all the variables on the other. So move that over. We're left with negative 75x equals negative 450. And then divide by negative 75, and you get positive 6. Oh. Wait, but they are, you mean at this step you have them both positive, or you added this by accident? Okay, always, and I know you know that, but make sure you always do the opposite. Okay. Anyone else? Steve, are you okay on 6? You can do that. You can do that, but then you end up with a 0 on this side. Did you maybe not keep a 0 on this side? Okay, then you subtracted wrong. Should have been 450. So you just subtracted, you did 1125 minus 675. When you subtract those, you should get 450. The way you did it, positive 450. Okay? You gotta make sure you're showing every single step. Okay. You just subtracted wrong. You just don't get why that works out to be 450 and not 650. Okay, did you do it on your calculator? Oh, so you wrote the wrong number down. Okay. Anyone else? Gio, please stop. Anyone else? Okay, anything 1 through 6? Okay, Josh, what did you get for number 7? Okay, good. So you could have 0.6, 60 cents, or 3/5. Good job. Any of those is fine. Neil, what did you get for number 8? You're off a little bit. Alexis? Good. 5.6 hours, or 28/5, depending on how you kept it. Maybe you, okay. Any questions on how to set these up, how to solve? Sure. All right, let's go over homework. So flip to 6.4. I mean 6.3, thank you. Thank you. Okay, we're just going to kind of fly through these. I'm going to ask you guys what you got so I can make sure that you guys did okay with this. Homework, please. Okay, 6.3. Joseph, we'll start with you. Number 1. Good. Jackie, number 2. Good. Nathan M., number 3. Good. Number 4, David. Good. Amberly, number 9. Good. Number 10, Shane. Good. Abigail, 11. Good. Greta, 12. Good. 13, Grace. Good. Peyton, 14. Good. Nathan S, 15. 30. 16. Ray. Good. 17. Skylar. Good. 18. Drew. Good. 4. Okay, let me just leave these up here for a second before I flip over. Make sure you have 1 through 4 and then 9 through 18 checked. Okay. Number 19, Michelle. Say that again. Good. 47. 20. What did I miss here? Amberly, go ahead. Good job. 60.2. 21. Kevin. You're off a little, unless I can't read my writing. Abigail. Good. 15. 22. Steve. Good. Camille, 23. Good. 11. 24. Neil. Oh, didn't get to that one. Joseph, 24. Good. Negative 36. Drew, 25. Okay, what did you get for 26? No. Are you doing multiply across both ways, like the butterfly thing? Okay. Okay, David, 25. Okay, Michelle, 26. Good job. And then 27 was the last one. Mike? Good. 300 defective machine parts. Okay. Before I ask any questions, does anyone need me to go back to the previous slide because you missed something? Okay. Any questions on anything on this page? Kevin? 21. Okay. 21, let me ask you this first. You multiplied across both ways, right? So did you write down that 15 times 48 is 720? Okay. So we have 15 times 48, which is 720. And then we have 30 times, in parentheses, x plus 9. Did you do that? Okay. After you distribute, we have 720 equals 30x plus 270. Still have that? Okay, so you might have thought that was a 20 instead of a 30? Okay, you just multiplied wrong. Okay. You okay? Okay, Skylar? Okay. Does anyone else need 21 before I move to 23? Okay, 23, Skylar, make your butterfly, and then we have 84 times x minus 4 equals 14 times 42 is 588. You had that right. After you distribute, you get 84x minus 336 equals 588. Had that still? Okay. Add 336 to both sides. So we have 84x equals 924. Say that again. You forgot that it was negative? Is that what you said? Okay. Okay. So it was just a problem with solving equations then. Yeah, just make sure you're careful, especially on a test, and you know whether it's a... Anyone else? Questions on that or anything else on the homework? Drew? What did you do? You wrote the problem wrong. Okay. 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 Just be careful on that. Nathan? That's fine. That's fine. Anyone else? Okay. Much less questions than I thought. Give me a thumbs up, thumbs middle, thumbs down. How do you feel about that? Proportions. Okay, awesome. Thank you. Okay, let's go to our notes. Okay, we need to finish up the geometry extension. So we are on page 10. We left off with line segment, which is right here. So at the very top of page 10, it will say, notes please, segments, rays, and angles. We're going to finish this up, and then I'd like to start 6-4. We'll see how this goes. Okay, so segments, rays, and angles. So the notation. Your book tells us that we can use capital letters for a segment and put just a line above it, or, sorry, a segment above it, or nothing. Yes? Yeah, quickly. Okay, so either put a segment above it or nothing. Both of those, the notation there means that is a segment. The diagram, you need to have endpoints for it to be a segment. Typically, you'll see capital letters. In the geometry book you'll see in 2 years, they always use capital letters with those. Okay. Okay, second one here is a ray. So not like ray here, right? So a ray has an endpoint on one end and the arrow going in the other direction. Now, your arrow here, which means your ray, could be flipped around here depending on which way it's drawn. The way I have it drawn here, D is the letter or point that keeps going on forever. C is the endpoint. So you want to make sure that these are lined up correctly. The endpoint letter is with the endpoint. The other letter is with the side that goes on forever. Okay? Okay, and then angle, which we talked about a little bit yesterday, or measure of an angle. So let's start with, let me start with this. Start with what's here. So there's two ways to name an angle. Okay, this is an angle symbol which kind of looks like less than, EFG. In geometry, Mr. and Mrs. Warnock will have you label the angle like this. Now, in your book, they use one letter. Okay, they use the vertex to name, Nathan M., you should be with us. We're already right here. They use the vertex to name the angle. So angle F. Now here's an angle that I drew, EFG. F is the vertex. So again, your book uses just the vertex to name the angle. I prefer that we use EFG, and make sure you go in order. You could go either this way or this way. It doesn't matter. Okay? That's to name the angle. Now I'm going to take you one step further. In geometry, you'll talk about the measurement of an angle. This little m means the measurement of this angle is, or the measurement of just the vertex. So I'm going to put a little line here. You'll see it either way. Your book does not have the little m to indicate, okay, this is the measurement of this angle. In the geometry book, you'll see that little m. Does that make sense? Okay. Any questions on how to name an angle or what either of these mean? Sure? Okay. All right, let's go to the next example, or the example underneath that. Okay, example here says we need to use the diagram to name two segments and their lengths, two rays and an angle and its measure. So let's start with segments. Can someone tell us one segment and what is the notation that we use to write down segment? Gio? Good. What else could we do? Put a line above it or a segment above it? Good job. Or just write MP. So there's a segment. Shane, what's the measurement of segment MP? Good job. So we found one segment and we wrote down what the measurement was. Steve, what's another segment? Good, PN. Steve, what has to go above it? Good. And make sure you're not putting arrows. You know, I know it technically looks like a line, but a segment, make sure there's not arrows. Joseph, what's the measurement of PN? You're ahead of us. PN, good, 6 centimeters. Okay, so there's two segments, and then we also found the measurement of them. Okay, let's move on to rays. Michelle, what's one ray? You said PN, right? Okay, PN. What side should the arrow be on? Should the arrow part be above the N or the P? Good job. So we want the N point above the P, the arrow above the N, because the ray is going on forever right here. Okay. Grace, what's another ray? Good. PM. And Grace, what the arrow is above which letter? Good job. P is the endpoint again. That's the vertex of the angle. So it's going to go on forever right here. The M is where it's going on forever. Okay? Check if that binder's yours, then yeah. If not, okay. And then let's go lastly to angle. Okay, what's one way that we can name the angle? We'll just come up with two ways here. Jackie? Angle P. Okay, good. There's one way, angle P. What's another way we, actually, let me do this. What's another way that we can name the angle? Greta? Good. Angle M, P, N. So going in order, M, P, N. The vertex is always in the middle. That's always how you name the angle, is by the vertex. But again, in geometry in 2 years, you'll see it this way. Okay, so those are the two ways. We now need to find the measurement of the angle. So put a little M in front of it, because we actually need to find what the measurement of the angle is. So measurement of angle, M, P, N, equals, Abigail, what's it equal to? Good, 80 degrees. So just a little bit of notation. Any questions on that? Okay, we have one more little section of definitions here. Okay, so let's look at that, and then we'll move on to the next section. Okay, so this little box or chart is labeled triangle, quadrilateral, and congruent parts. In geometry or any geometry section of an algebra book, notation for naming a triangle is you have a little triangle in front and then 3 capital letters, A, B, C, based on what the vertices are. Okay, so notation is little triangle in front and then capital letters, A, B, C. And I just put an example. That's one vertex. They're all vertices. But I just had one example up there. Come on, you stay with us. Okay, Steve, quadrilateral. How many sides does a quadrilateral have? Good. What's one example of a quadrilateral? Josh? Good. Square. What's another example of a quadrilateral? Abigail? Good. Rectangle. What's another example of a quadrilateral? Mike? Good. What's another example of a quadrilateral? Gia? Good. Trapezoid. We could keep going, right? Rhombus. I know. We could keep going, right? There's a lot of them. I just figured I'd stop there. Okay, so a quadrilateral right here, feel free to write down what you want here, is made up of 4 segments that intersect only at their endpoints. Okay? There's a bunch of different quadrilaterals. You will classify and categorize polygons, again, in 2 years. We will do it a little bit more in chapter 10 of your book. That's what we'll end the year on. Quadrilateral PQRS is one way to name it. You may also name it with a little quadrilateral in front. That should be a quadrilateral. And again, you'll talk about this a lot more in geometry. And then here's an example of a trapezoid that doesn't look so perfect. But there you go, PQRS. And we'll get to congruent parts in a second. Okay, is everyone with me? Ben? Oh, no. I read it this way, PQRS. And I'm going to get to that in the next section. When you're given a name of something, Ben, you want it to go in that order. So PQRS, you're reading it this way. You can technically name this however you want. If you'd rather name this PSRQ, that's fine. But if the problem gives it to you like this is how we have to identify it. Okay? Anyone else? All right, let's go to the example at the bottom. Okay, we're going to identify just one of each. Okay, we're not going to identify all of them. Okay, so on the triangle that's on your paper at the very bottom, what's one angle? And I want you to use 3 letters to name it. So what's one angle here? Peyton, can you give us one angle? Good. So angle YXZ. So Peyton used YXZ, which really refers to this angle. YXZ, right here. Okay? That's one of them. You would have a little m in front if you were finding the measurement. Okay, what's one side and what's the notation that we use? Joseph, what's one side and what's the notation that we use? You tell us. What do you think? Okay, X, Y. Why is it a segment? Why is it a segment? Good job. Definition of a triangle is you're going to have three sides. The vertices are going to intersect. So that's going to create an endpoint or a point or a vertex. So it's going to be a segment. Okay, you're not going to see a triangle that has lines like this going on forever. You might, but typically it's not like that. There's three segments. Okay. All right. Congruent angles. You guys remember from yesterday? Do we have any congruent angles here? Kevin? Okay, why? Good. This little curvy thing, half circle, whatever you want to call it, means they are congruent. So X and Z are congruent. So let's write that down. Angle YXZ is congruent to angle YZX. What is the symbol for congruent? I skipped that part on purpose. Amberly? Good. An equal sign with a little squiggle above it. Now that looks much better than mine that I drew yesterday. So that tells us that angle X and Z are congruent. Now, yes, you may just say angle X is congruent to angle Z if you prefer. I will not mark that wrong in a test because your book does it that way. Okay, I'm just doing it this way because that's what you'll see in 2 years. Ray, were you going to ask that? Okay. All right, congruent sides. Just by looking at that, do we have any congruent sides? Peyton, what are they? Good. Okay, Peyton, are they, what are they? Are they segments? Are they lines? Are they rays? Good, segments. And then make sure you have the congruent symbol in between them. This little tick mark indicates those are congruent. Okay, any questions on that? Okay, let's flip over your notes, okay? Okay, flip over your notes. Let's go to page 11. Skip the warm-up. Well, we'll do that one a different day. Just so you guys know, this is a proof. I showed the 6th graders this last year. We'll get to that. I might show you one of those later on. A proof. Okay, congruent figures. I want you to jot down here. We talked about this briefly yesterday. If two figures are congruent, they're going to have the exact same shape and the exact same size. So if two figures are congruent, they're going to have the exact same shape and the exact same size. I then made two triangles, A, B, C, and then the other one is D, E, F. Please note that when you're naming them, the angles that are congruent have to be written in the same spot. For example, the A and the D are both first. They correspond and are congruent angles. The B and the E correspond. They are congruent. They are in the same spot. Okay, now I drew all those tick marks and all those little curvy lines to indicate all the sides are the same, all the angles are the same. That's what it will look like when two triangles are congruent. Same thing goes for any polygon. So a congruent figure, you guys know the symbol from yesterday, an equal sign with a squiggle line above it, same shape, same size. Can anyone tell us the definition for similar figures? What does it mean if things are similar? Not congruent, but similar. Ben? Nope. Close, though. Drew? Okay, right. Same shape, but not necessarily the same size. So Ben, you were close. I just don't want you to say one or the other, because that's not always true. Okay? So from your book, definition is, and you don't draw all this, I just want you to write this down. Two figures that have the same shape, but not necessarily the same size. You don't have to write all this, but for example, here's two triangles. They have the exact same shape, but not the same size. if they're similar, this might take it a step further, but if they're similar, the angles are going to be the exact same, but the sides are going to be proportional. That's what we're going to work on today. So I'll say this one more time. Oh, and I had this up here. The angles are going to be congruent in similar figures. The ratios of the sides, in other words, if you set up a proportion of the side lengths, they're going to be equal. All the ratios of the sides are going to be equal. So here's an example. Look, 4 corresponds with this side, which is 8. 4 over 8 reduces to 1/2, right? That's a ratio. 3 over 6, they correspond. These are the same sides. They're similar. 3 over 6 is 1/2. And then look at this one, the hypotenuse here. We have 5 over 10, which reduces to 1/2. If all the ratios are equal, you know it's similar, okay? If all the angles are congruent, it's similar. So same shape, but not necessarily same size. Did that make any sense? Just give me a little head nod if that made sense. Okay. And feel free to write this in your own words if you want. You do not ever have to write my notes verbatim, okay? Feel free to write down whatever makes sense to you. Peyton? Go ahead. Yeah. 3 lines, okay. 1 tick mark, and we talked about this yesterday a little bit. 1 tick mark means these sides are the same. 2 tick marks means these sides are the same. 3 tick marks means these sides are the same. It doesn't necessarily mean that it's equilateral and all the sides are the same. This is definitely not drawn to scale because it looks like all the sides should be the same. Is that why you were confused? Okay. Yep. If they were all the same, if it was equilateral, okay, equiangular, you'd have 1 tick mark on all the sides for both of them. Yeah, good question. And remember, things are not going to be drawn to scale a lot of times. You'll see that in your book. If we get to that for homework, it'll say not drawn to scale. Okay? Any other questions? Okay, corresponding parts I already told you, but let me show you what the book says here. Corresponding parts are sides or angles that have the same relative position. So after you write that, I'll explain from this diagram. Okay, so a corresponding part, here's an example. AB and DE are corresponding segments. AB and DE, they're in the same relative position, right? This right angle, which is A, and this right angle, which is D, are corresponding parts. They're in the same relative position. So A and D are corresponding parts. C and F are corresponding parts. Their angles are in the same relative position. That makes sense? Okay, I'll give you one more. BC, which is the hypotenuse, is corresponding to EF. They are in the same relative position. Okay. Okay. Any questions on anything on here? Okay. Let's do one more thing here, I think, and then I'll let you know what I want you to do for homework. Okay, so first thing, they give us 2 trapezoids, okay? And they tell us here, and I should have told you this, I forgot, this little symbol means similar. Okay, so if it's just a squiggle, that means that the figures are similar. Same shape, but not necessarily the same size. So this right here means these 2 trapezoids are similar. Now, they are not drawn to scale. Ben? It just is not in there. The book names them. They don't have, the letters do not have to go into consecutive, they don't have to go in order. Do you know what I mean? They do, but they don't have to all the time. You could have a triangle named AZB. Okay? What'd you say? Okay, I'm sorry. Next time I'll make sure the book puts O in there. All right. Yeah, but they don't always use all the letters, Ben. That's a good question. It's not always like nice, neat, and perfect. Okay? Okay, first thing I want you guys to do is we know LMNP. So look, LMNP, which goes in this order. is similar, just a squiggle means similar, to QRST. What is wrong with this? Abigail? It's upside down. I want you to redraw it. Okay, so let's redraw our trapezoid. I am not good at drawing. You guys know that by now. That's what Abigail just said, Ben. Okay, so redraw it, and we're going to write them so they correspond with this trapezoid. Okay, so L, M, N, P has to correspond with Q, R, S, T. So Q goes here, Q corresponds with L, so they go in the same spot. R corresponds with M, so they're going in the same spot. They're corresponding parts, same relative position. S and N go together, so the N is here, the S has to go here. And then lastly, T corresponds with P, so the T has to go on the bottom left-hand corner, just like P. First thing I want you to do on homework or any test is redraw your figure so that it's in the same relative position. Does that make sense? Okay, we now need to list all pairs of corresponding sides. So Shane, can you give us one set of sides that are corresponding? Good. LM corresponds with QR. Now I'm just putting a little squiggle between them because we know they are similar. The sides are proportional, which means the ratios are going to be equal. Okay, Abigail, can you give us another one? Good. M, N, and RS. Please notice how Shane and Abigail both gave it to them in the correct order. For example, LM goes with QR. You cannot say LM goes with RQ. You need to make sure that you're being consistent. The one Abigail gave us was MN goes with RS. Make sure they're going in the correct order. Okay, Mike, give us another one. Is proportional or corresponds with PN. Okay, and then the last one, there's one more. Greta? Good. PL corresponds with or is similar to TQ. You can say it either way. Okay, questions on the corresponding sides. Okay, if it's similar, if the two figures are similar, what do you know about their angles? Always. Peyton? Good, they're the same. So what's one set of angles that are congruent in these two trapezoids? Alexis, what's one set of angles? You can just tell us one letter since it's not a triangle. Good. Angle Q and angle L are congruent. Since we have a trapezoids here, you can use 3 letters to identify the angle. Just because of time, let's just use one. Okay, Michelle, what's another set of angles that are congruent? You can just give us one letter. Did you hear what I said? That's okay. Good. Angle S and angle N are congruent. Ben, what's another one? Michelle just gave us that one. Give us a different one. Doesn't matter the order of these. You're still saying they're congruent. Okay, good. P and T. And then the last one, Evan? What goes with M? What's corresponding with M? Good. Okay. So similar, the sides are proportional, or you could say the ratios are equal. The angles are always congruent. Any questions on this so far? Okay, let me give you homework. I know I need to finish that tomorrow with you. That's okay. Okay, hold on before you write that down. Okay, I want you to do on practice 6.4, numbers 1 through 7. Do you want more? No. Okay, that's all, because I didn't. So here's what I was just thinking in my head, in case you're curious. There were 10 problems in the book that were similar to the extension that I finished today. We started yesterday, but these problems are actually better practice for what we need to finish tomorrow. So yeah, just 1 through 7, but also don't forget about test corrections if you still have to do that. Those have to be turned in tomorrow, okay? So yeah, just 1 through 7. On 1 through 6, I'd like you guys to draw the quadrilaterals, okay? So EFGH, it tells you, is similar to JKLM. Draw them, please. Number 7, redraw the second figure, just like we did on the trapezoid problem in the notes, okay? It's, Steve, what? 1 through 6? Yeah, you're supposed to draw them. You drew each of them? Yeah. No. For 1 through 6, just draw 2 figures. You can use the same ones for all of them. Okay, Skylar?